Hello, my name's David. I'm with Atlantis Technologies. I'm here today to show you how to do a pH calibration, a 3-point pH calibration, on a Walchem Intuition 6. This is the same thing as doing what you're going to need today to do a 3-point calibration is your 3 buffers, which I'm using 4, 7, and 10. And you're going to need some fresh water to clean the probe between the buffers, and you'll need a paper towel. It's that simple. So as you're going through your buffers, you want to make sure you never contaminate from one buffer to another. Controller set up so that it has a pH probe and it can feed acid or caustic depending on the set points that are in there. Right now I have a sensor in tap water and I'm just going to show you how to go through this. You may want to turn the acid and caustic pump off before you do this whole process. It will turn them off automatically during the calibration, but I always like to do a check at the end. So first thing I'm going to do is go to the HOA and I'm going to turn the acid and the caustic off, go back to home. The next thing I'm going to do is take my sensor, I'm going to wipe it off, and I'm going to put it in the pH 4 buffer. And just to support it, here I'm putting it in this cup so I don't have to hold this the entire time. And I generally wait and watch for the reading to stabilize before I start my calibration. It just makes it simpler because this isn't an instantaneous thing. So as you can see, it's dropping right now on the screen. We're somewhere in the 4.27. It seems to be pretty stable at this point. So if I go into either inputs or even just select pH there, I can hit this little target button. And the target button gets me to all the different calibration. Got to push it a little bit harder. Takes me to all the calibration choices. So you have a 1-point process calibration if you just wanted to adjust inline without doing any calibration. You could do a 1-point buffer calibration. You could do a 2-point or a 3-point. I suggest you always do the 3-point, especially if your pH can go anywhere from, say, 4 to 10. That gives us a good adjustment to go from 4 to 7 and then 7 to 10 in the control unit. So we're going to go ahead and do the 3-point buffer calibration. It asks if we want to disable control, which we've already done, but we say yes, go ahead. And it'll ask what buffer are we using first. So we've already let this thing stabilize in 4. So I'm putting it in 4, putting in the value of 4, and I'm going to hit confirm. And it'll tell me go ahead and put it in there. We've already done that. So I can confirm, and now I'm going to wait for it to stabilize, and it'll do its own stabilization, and then it'll tell me to continue whenever it thinks everything's all right. So now it's telling me to go to the second buffer. Now I normally go just 4, 7, and 10. It may tell you something else, but we're going to do 4, 7, and 10. So I'm going to clean the sensor off. I'm going to dry the water there so I'm not contaminating my next buffer. I'm going to put it in the 7, and I'm going to let that sit here. And we're going to have a time delay right now because we got to wait a minute or so for this to stabilize. Anyway, I wait for a few minutes, and then I finally say, okay, we're at 7. I'm going to confirm. It's telling me to put it in there. I've already done that, and I've let it stabilize a little bit. And I hit confirm. And it'll show you the values coming up. And it's still changing a little bit, but we'll wait till it stabilizes. It waited, it's done. Now it's waiting for the third buffer. Now our third buffer, after we clean our sensor to avoid contamination, I put it in the 10. Put it back in my holder here. Again, I'm going to wait a little bit. I'm going to go ahead and, while I'm waiting, I can put the value of 10.0 in here, my third buffer. I wait for a minute or two. So after I've waited some, I hit confirm. It'll tell me to go ahead and put the sensor in that buffer, which I've already done. I hit confirm, and it'll stabilize and it'll get a value. Now after it does this 3 points, you'll get 2 gains and 1 offset. You see all the offsets are the same. And this is just what the controller is using to get a value, and it asks you if you want to save it. Well, as long as these are within, say, 0.8 to 1.1 over in here, and your offset's within plus or minus 30, I feel like it was a pretty good result and that the sensor's working properly. So I like this result. I'm going to hit confirm. It says, do you want to rinse the sensors and return it into the process? And I say, yeah. Now, at that time, it would start using the relays again, which is why at the very beginning I turned them off. And I'm just trying to make sure that we're not feeding a bunch of acid now, that it's sitting here in a buffer of 10. And the reason I do this is I want to see what readings I'm getting just to verify that the calibration was working. So I'm sitting here at 10. I've got a millivolt value of minus 180.3, minus 180.4. So obviously it reads 10 very well. And I'm just doing this to verify that the whole calibration process was accurate. So if I put it in 7, we'll see if it goes to 7. And my goal is if I'm within 1/10 of a pH unit, it's a pretty good calibration. So we're closing in on 7. .99, 6.98. I'm happy with that. So I will clean it for the last time here. Go to pH buffer 4. Stir it around a little bit. Wait and see where this stabilizes. Seems to be bouncing around 4.04, 4.05. I'm happy with that. If I now go back into my HOAs, I can turn on the 2 relays. You'll see the caustic's feeding right now because we're around 4. I'm going to put it back into my process. Which my tap water before was around 7, 6.8 I think. And we are done. Thank you. During this calibration process, we got a successful calibration, but what happens if you get a failed calibration? I mean, the controller will tell you flat out, hey, it failed. But you can also look at it like I was discussing on the gains and the offsets, and you can look at that and see how bad was your calibration or how bad's your probe. Maybe it won't read below 7 anymore. And a good indication of that is the millivolt readings, even before you do the calibration. If you look at the millivolt ratings of a sensor, and if you didn't have it on your front screen, you can go to inputs, you can go to pH, and it'll show you the raw value of the sensor. So right now I'm in tap water and I'm reading 19 millivolts approximately. The way this works is theoretically there should be about 59 millivolts per unit from 7, and it's opposite of what you'd think. As you go down, it's a positive number. As you go up, it's a negative number. So 59 millivolts from 7 to 4, which is 3 units, would be 59 times 3, which is 7 minus 4. That should be around 177 millivolts. So if I take this sensor and I put it in a pH buffer of 4, I should get somewhere around 177 millivolts, theoretically. So you can see on this controller, I'm not. I'm getting somewhere around 158. That's not bad. If it's within 30 or 40 millivolts on that, it's going to calibrate, it'll be fine. But if you're concerned about your probe not functioning before you do calibration, one easy thing to do is look at the raw value. You should be theoretically around 177 millivolts in 4. You should be around 0 in 7, and you should be at negative 177 when you're in 10. So it just gives you a good indication of whether the probe's functioning or not before you even do a calibration, or if you have a failed calibration, you can go back and look at that. So if you failed a calibration, you take a look at those millivolt readings. That'll give you an indication on whether you should try this again. Maybe you were too fast. Maybe whenever you actually were going through this, you didn't let it stabilize enough. And then when you went back and put it in your test buffers, it was not even close. So that could be something where you didn't take enough time between allowing it to go ahead. And that's something that, I think the more patience you use, the better on that. The other things are, if you get a reading, you're looking at these and you see the reading seems to be way off. It's 100 off instead of the 177 or the negative 177. It's probably a good time to change the probe. These probes have a life, if you're really lucky, you might get 2 years out of it. Typically, they're about a year, but it all depends on your process. You might only get 4 or 5 months out of it if it's a really hot process, if it has something that's aggressive, that's hard on the probe, or if you have something that really starts plugging up this white junction ring there. It could shorten the life of it. So if you see that you're not getting the millivolt readings even after you've cleaned it, then it might be time to get a new housing. Talking about cleaning, that's something else we ought to bring up. A lot of times I'll go out to a plant, and when I take a look at this, I'll see a haze over the glass. That's something in the process is coating the glass, and you really need to cut that out. So in order to do that, you try something like a muriatic acid or a caustic or a CLR, and you can dip it in there, then rinse it off and try to wipe it off. You don't want to just soak it in those things. If you are soaking it in those things, it's really hard because it's basically shorting out a battery whenever you put it in a really strong acid or caustic. That's why we say use something gentle like a muriatic acid, even a diluted CLR, which is really an acetic acid. Those things will work, and they'll cut that off, cut that film off, and if you can get that cleaner, that'll make the probe work faster, and you'll get a more accurate reading. If you need a new cartridge, don't use any tools. You should be able to do this just with your fingers. Hopefully somebody didn't really tighten this thing in before. All right, so I'm going to put a new electrode in this, so I get one out of my box here. They come in a storage buffer in a little vial like this. You unscrew the cap, you take this out, and there's a storage O-ring. We want to get rid of that. So we pull that off. Do not install that on the probe with that red O-ring because it will not work. You won't get a tight seal and you'll get a leak. And if you get any water up in this housing, there is an amplifier in it and you will ruin it. So put this in here, push up firmly, start turning, and you want to turn until this O-ring is totally gone. It'll get tight, and now when you look there, you can't see the O-ring. That's sealed. Water won't get in there now. And now you're ready to put this back in the process or in your buffers. You never want to put the flat part of the probe right on the bottom of the beaker or the glass. So I always put it in here on an angle, or I'm resting it on top of here. When I have it sitting inside this cup, you'll notice that I'm trying to put it on an angle so that it's not flat on the bottom of the glass or it's resting up on the probe. When you go to clean a sensor, remember this glass on the bottom is very thin, so you just want to touch it very gently. You don't want to press on it or you'll break it. Thank you for watching our video. Hopefully this has helped you with calibrating a pH probe and understanding how it actually functions. If you have any questions, feel free to give us a call here at 724-695-2900. Thanks.